In this video, we're going to talk about how to calculate the expected value, the mean, and the standard deviation and variance for the binomial distribution. So the equation is up here. So the expected value of x, mu, equals n times p. And then here's the equation for the variance, np times by 1 minus p. So for the expected value, right, it equals mu, which equals n times p. So remember for our example that we talked about before, if 3 people enter a store and the probability of purchase is 0.3, right? We have n times by 0.3 is 0.9. So this is the expected value or the mean. So two things. One, let's interpret this, and then two, let's better understand where this equation came from. So first of all, let's talk about where the equation came from. So remember when we looked at the expected value of a discrete random variable, this was the equation that we had. Right, the sum of x's times by the weights, the probabilities, that would give us our mean. Do you remember doing that earlier? So remember, the binomial distribution is basically, it falls under the umbrella of discrete probability distribution. So when we have a discrete random variable, this equation, it should actually apply to the binomial distribution, right? Because it's a special case of discrete probability distribution. So this was our example earlier where we talked about x, right? The values for our random variable x, and then the function of x, the probabilities, we calculated those. So if the expected value for a discrete random variable is equal to, right, all of the x's times by their respective probabilities and summed together, right, that's the equation, this actually should be the same as this value, right? Because this is just a special case, the binomial distribution. This expected value is just a special case for a discrete random variable. So let's actually check that. So if we multiplied x times by the function of x, right, the weight, its probability, 0.340, that's 0. 1 multiplied by 0.441 is 0.441. 2 times by 0.189 is this. 3 times by 0.027, right, is 0.081. So if we took these values and we sum them together, right, the sum of x times by the function of x, right, which is what this equation is here, x times by their weights, sum them together, guess what we get? 0.9. And that makes sense, right, because that is our mean. And this case, right, the binomial distribution, this expected value for it, is just a special case for the discrete random variable. So this equation, where does it come from? Well, I proved to you just now that this equals this. So that's basically how you can create the expected value for the binomial distribution. So the second thing I wanted to talk to you about is the interpretation of this. So basically, like, it's a little confusing because you see 0.9 and we're so used to seeing a number between 0 and 1 that, oh, it must be a probability. This is not. Remember, it's an expected value. It's a mean. So, right, these are our values for our random variable x. So this is the mean of that, right? Considering all the probabilities, it's actually the mean of it. So it's basically saying that this is an average. So, considering our example, right, if we have 3 people, the probability of purchase is 0.3. The average number of people making a purchase is not even 1. So this is an average. This isn't a probability. So I just want to make that clear because I know sometimes we see 0.9, we think that that's a probability. It's not. It's the average, right? It's the mean. It's the expected value. So basically, right, like I said, if 3 people walk into the store, the probability of purchase is 0.3. Right, how many sales basically, or how many people making a purchase is, right, what can we expect? What's the average? Well, not even one person. So so how can we increase that, our sales? Well, right, even increase N or increase P, right? Get more people going through the store, right, entering your store, or increase the probability of purchase. So you marketers out there can figure that part out. And then the variance and the standard deviation, right? Standard deviation is just the square root of the variance. So how do we create the variance? Right, the equation's right here. So I'm not going to go through the proof with you, but again, it's a similar principle. We have np times by 1 minus p, right? So we got n is 3, p is 0.3, 1 minus 0.3, 1 minus p is 0.7, so we get 0.63. So that's a variance. The standard deviation, therefore, then is 0.79. So now we know what the average, the expected value of the discrete random variable, the binomial distribution is, as well as the standard deviation and the variance.